Hi everyone and welcome to the channel. Today I'll be making a preface for the requirements of Euclid's elements. So let's get into the mind map. So from the Noumena video, the most primitive notion is that of existence itself. And here we find the true nature, the true essence of Platonism, which is Noumena and well-defined concepts. So mathematics exists a priori and therefore is discovered. And before we begin to reason, we must at least know what it means for a concept to be well-defined. Definition of well-formed concept is necessary but not sufficient to move on from here. So existence in our reality experience is tied with the idea of location. Existence is inseparable from the notion of space. There's a spatial relation. And just go ahead and try to think of existence, and the notion of space, of locality, of location always comes up. So let's move on to a thought experiment. So in the next part of this series, we will go through all the previous with diagrams or the use of a compass and a straight edge for visual aid. But for now, we can just try to use our brains and do this thought experiment without drawing any diagrams. So the concept of location. We begin with the concept of location. In an empty universe, excluding our brains and naturally us, the concept of location can be defined only primitively and developed gradatim, so gradually. One cannot even talk of the basic concepts such as direction, path, distance, coordinate, plane, space, or dimension at this time. All of these need to be defined gradually, starting with the first concept, i.e. location or point. So realization, or getting the idea of the concept of location. This occurs when we ask the simple question, where? In an empty universe, the first definition of location is primitive and has only two values, here and not here. So what is here? Here is simply where we are, and what is not here is where we will be if our location changes. So now to the next step. Now we are ready to realize the concept of path and direction. So path. A primitive definition of path is a method of moving from here to not here. The next step is to introduce another object in the empty universe besides ourselves. That object can be inanimate or just another sentient being, or let's say a friend. The logical subsequent idea is how to change location or go from here to not here. So motion is defined as the change in location. So direction. Realization of direction. Realization of direction happens by the question, how to change location or go from here to not here. For this, we need a means of sight. We could think of sight in our minds as an ability to identify a particular location. But to make matters simple, I'll introduce light in the empty universe, which enables us to see. So primitive definition of direction. A primitive definition of direction can simply be thought as toward or away. Oops, sorry about that. So away. Sorry, it's buggy sometimes. So we know that being here means away from not here. So if any change in position or location results in us being not here, then we have moved away. And toward, on the other hand, any change in location that results again from not here back to here means toward here. So we continue on with again a primitive definition of motion, but now slightly more in depth than the previous. So motion. Motion involves change in what we see at the destination location from where we are. It involves no change at all in what we see, not even the slightest. And a note here, at this time we have no concept of plane or space or dimension yet. Motion, as we know it, can be taking place in any random way. So, reasoning between two locations. Instead of saying actually two locations, if we want to be very strict, we can say a location and another location, because we don't really want to use number yet, since we haven't defined number. But we can talk about, let's say, to define a point A and then define another point B without talking about number. So, reasoning between two locations. It is possible to have more changes or less changes in motion, because if our destination changes just once, then already that particular path will not be equal to the path where what we view remains unchanged. Since we can move at random as we please because we haven't even realized the concept of boundary yet, it becomes clear that we cannot determine all the paths possible between any two different locations. I could have written that we cannot determine the innumerable paths, but I refrain because we're still way off from realizing the concept of number. Numerable directly implies that the concept of number has been established. So now we're in a conundrum. There are so many paths, and it's daunting to think about the relationship between any two of these paths. We can call paths the same or equal if the change or movement from source location to destination location involves exactly the same movement, here to not here, or vice versa. From this we realize the concepts of less or more movements, shorter or longer in any given path. This reasoning leads us to the possibility of the existence of a path requiring the least changes. So from this we infer that the path consisting of only those same movements from start location to finish location is the shortest path. The shortest path is the realization of a straight line between two locations. Sorry about that. So note that I haven't even talked yet about dimensions such as plane or space. In fact, we can't talk about these until we realize the concept of circle, which can only be realized after the second requirement. So yes, we have not defined plane, sphere, etc. So the argument about geodesics does not hold. This is the typical argument, the non-Euclidean quote argument, that in non-Euclidean that there's infinite lines that connect two points. So first of all, these are not lines, these are geodesics, and as I said before, we haven't defined plane or sphere yet. So the criticism doesn't really hold. But even if we consider it valid, we can easily just add something to our definition and then it's totally robust. The previous criticism, which was lacking anyway, but it can't hold. So if we add, if and only if there is a unique shortest path, that connects 2 points, then that's totally bulletproof. So that's requirement 1. It's the unique shortest path that connects 2 points. So I think this is it. Actually, I would like to make a last comment. So do you now see why these axioms are not arbitrary, and they're not axioms, they're requirement. They aren't taken on faith. We start with the absolute most primitive notions, and we build up gradually in an irreducible way, and there's perfect succession. So this will sink in more and more as we go through the other requirements, and it's apparent that all are perfectly connected, as I said. So this is it for this video. I might go over this preface again in a sort of constructive way, using diagrams and maybe a compass and a straight edge to let these ideas sink in better. So thanks for watching, and I'll see you in the next one. Bye.